Lecture 10.3, Day 1, Polar Coordinates. One way to give someone directions is to tell them to go 3 blocks east and 5 blocks south. Another way to give directions is to point and say, go a half mile in that direction. Polar graphing is like the second method of giving directions. Each point is determined by a distance and an angle. A polar coordinate pair r theta determines the location of a point. The angle is measured counterclockwise from the initial ray, which would be horizontal on the x-axis, and r is the radius, which is the distance from the origin. Some curves are easier to describe with polar coordinates. For example, r equals a describes a circle centered at the origin. Theta equals theta sub 0 is a line through the origin. And this, r is between 1 and 2, and theta is between 0 and pi over 2, gives this shape. More than one coordinate pair can refer to the same point. This illustrates 2 30 degrees, but it could also be -2 210 degrees. This might be a good time to mention that an unfortunate aspect of polar coordinates is that the distance is given first, and then the angle. But if you're actually going to draw the point, you need the angle first, and then the distance. This point could also be -2 -150 degrees. All of the polar coordinates of this point are 2 30 degrees plus n times 360 degrees, and -2 -150 degrees plus n times 360 degrees, where n is 0, plus or minus 1, plus or minus 2, etc. In other words, n is an integer. Tests for symmetry. X-axis symmetry occurs when, if r theta is on the graph, so is r negative theta, as in this graph of r equals 2 cosine theta. Y-axis symmetry occurs when, if r theta is on the graph, so is r pi minus theta, as in this graph of r equals 2 sine theta. Or -r negative theta. Origin symmetry occurs when, if r theta is on the graph, so is -r theta, as in this graph of r equals plus or minus radical tangent theta over cosine theta. Or r theta plus pi. If a graph has two symmetries, then it has all three. For example, r equals 2 cosine 2 theta. Let's graph this equation on the TI-nspire. R equals 2 cosine 2 theta. Press Menu 3, Graph Entry Edit, 4, Polar. Insert the polar equation and the domain. Then press Enter to see your graph. Since that's kind of small, we'll adjust the viewing window to enlarge the graph. But now the graph looks distorted, so we'll use Zoom B to square it up. This shape is called a four-leafed rose, although to me it looks more like a daisy than a rose.